Hello! Untitled Algebra students, Mr. Lawrence here, and we've got a little video. I apologize for not being able to be there today. I'm at a meeting up at the board office. I'd much rather be with you guys and girls helping you out. All right, so here's what's going to happen. You're going to take some notes on this video. I've got some sample problems from Chapter 4. The video won't take, 4, 6, and 7. If you need to watch the video again as a class, that's fine. I'm going to go through some more complicated problems, a little bit slow. And then I'm going to assign in digits the Chapter 3 review like we did. And so when we're done with this video, you have a choice of working on the Chapter 3 review, or you can work on your midterm review, from the web page. Anything like that, you can get the computers out, all that good stuff. Okay, so let's get on with the video. So the first problem I want to talk about says Stanley is in the middle of a growth spurt. He started the school year 5 foot tall. Since then, he's been growing half an inch every week. The growth spurt will last for 18 weeks. Identify the independent and dependent variables and write a function that can be used to determine how tall Stanley is at the end of every week. Determine the domain and range of your function. Does this data represent continuous or discrete data? All right, the first thing we are going to do here is we are going to identify our variables. And when I go to identify my variables, I'm looking for the things that are changing. Now it says right here where is it? I can't find it. Write a function that can be used to determine how tall Stanley is at the end of every week. I see my two things that are changing. Yeah. One, his height is changing, right? How tall he is, right? His height is changing. And two, it's every week. The weeks are changing. Now I have to ask myself, which one is the independent variable and which one is the dependent variable? And I want to remember that the independent variable causes change in the dependent variable. All right? If I was going to say, I don't know, throw a football to Nick Olson. Nick has a lot of reactions. He might ignore it and let it go by. He might let it hit him. He might try to catch it. He might actually catch it. He might get hit by it and then yell at me. He might catch it and then throw it back. Who's acting independently and who's acting dependently? Well, Mr. Lawrence is the one acting independently because I am causing a change in Nick's behavior. So in this simple example, Nick is the dependent variable. If I don't throw the football to him, none of those other behaviors occur. He does what he's doing right now. Hopefully he's not doing anything embarrassing. Everybody look at Nick. Make sure he's not picking his nose or anything. If he is, say, ooh, that's gross. All right. By the way, where's the scene? Okay. So I have to identify my independent variable and my dependent variable. Well, let me ask myself, the height, is that causing a change in time in the weeks? Or are the weeks causing a change in the height? Yeah, the weeks are causing a change in the height. Good job, Maddie. I knew you'd get that. So the independent variable are the weeks or the time. I like to use weeks because it's more specific. All right? You could use time, but I like it because we're specifically talking about weeks. And then the dependent variable is the height. Okay? Now I'm getting ready to write my function. Well, remember the independent variable is the input. It goes inside the function. So I'm not just going to write h, I'm going to write h of w, where the h is the function machine and the w is the input. H of w is the output. So what does he start with? Well, he starts 5 feet tall. But Mr. Lawrence, you wrote 60. Why would I write 60? Well, you see he's growing at a rate, where is it at, of ½ an inch every week. So I converted 5 feet to 60 inches. Yeah, just 5 times 12. Okay. Now, if this is my function here, 60, well, it's not finished. What's happening every week? Well, I'm adding 1/2 of an inch per week, right? Now, just a little check. This is not necessary, but just to make sure I'm doing this right. How tall is he at the start of the growth spurt? Well, that would be 0 weeks have gone by. So that'd be 1/2 times 0, which would be 60. And therefore, he's 60 inches tall. And I like this function because it gave me his height at the beginning. All right, so that's the function I'm going to go with. H of W equals 60 plus 1/2 W. All right, so there's my function. Now, I have to determine the domain and the range. The domain references the input, what the input is allowed to be. Well, the independent variable is also concerned with the input. And so the independent variable is W. So I want to know what are the limits on W. Well, W looks like it's going to be between 0 and 18. It's going to be somewhere in there. So I'm going to sandwich double in between these two. W in between these two. And there is my domain. Oops. Silly me. Pardon me 1 second here. All right. Because the weeks go from 0 weeks at the start of the growth spurt to 18 weeks at the very end of the growth spurt. That's what I'm doing there. Okay, and notice that is an and. All right, the range is done similarly. I want to figure out all possible values for his height. Well, at the start of the growth spurt, how tall can he be? He could be 60 inches. At the end of the growth spurt, I believe he can be 69 inches. Okay, because 1/2 times 18 would be 9. And if I add that to 60, he's grown 9 inches. That'd be 5'9" if I wanted, but I'd like it better in inches. So the range has to be in there. So the minimum value is 60. I'm not going to put H, I'm going to put H of W because that's my output. And that's going to have to be less than or equal to 69. And there is my range. Okay, so I've done domain and range. I've done independent, dependent, and I've written a function. The only thing left is, does this data represent continuous or discrete data? And so I'm going to ask myself how he's growing. Maybe I'll make a little graph here. Sometimes the graph can help me really understand discrete or continuous. Okay, now this one's not the best of graphs because I'm only concerned with the first quadrant, but all I need are a few points to see what's happening. So this is going to be 0, this is the weeks, and this is the height, right? And we'll say 1, and then 2, and then 3, 4, 5, 6. And I'm not going to make the entire graph. All right, and so let me see here. If I count by, let's go ½ an inch, 60. If I can't count by 60s. If I make this 60, 20, 40, 60, but he's only going up to 69, so yeah, I don't really like the way this is going. Tell you what, let me get rid of this here. And let me just make kind of a sketch graph. It'll look better. I thought, oh, I'll do it on craft paper, but in this situation, it's just going to be kind of a pain. Okay. All right, and so here, again, it's going to be 0, 0, and this is the weeks. And then we're going to have 1 week, 2 weeks, 3 weeks, 4 weeks, and that'll be enough for me to see what's going on. Okay, and I'm going to make 60 up here, and then I'll make 70 here, ballparking it. Okay, so 1 week, or 0 weeks, he's at 60, right? 1 week, he's ½ an inch, So let me see, 5 weeks, he should be at 70 inches, right? So at 5 weeks, he should be right there. Now there's going to be all these other little points here along this line. Now the real question you have to answer is, would this data be discrete or continuous? Do the points in between the data make sense? Like, for example, if we've gone a week and a half, can we predict his height somewhat accurately? And the answer here would be yes, because he doesn't grow in steps. It's not like, okay, Sunday, he's 60 inches. And then there's Monday, Tuesday, Wednesday, nothing's happening. Thursday, nothing's happening. Friday, nothing's happening. Saturday, and then it's Sunday again. And all of a sudden, he's 60.5 inches. That doesn't make any sense, right? He's gradually growing. So this data would be continuous. So it might look something like this. And obviously, they'd be perfectly linear if I was on a graph. I apologize for them not looking quite so perfect. All right, so this is continuous data. All right, lost a problem there. Okay, now this next problem here, I want you to pause the video and go ahead and try and do it on your own, and then you can see my solution. So everybody's got their notebook out. Hear that, Connor? You got your notebook out? Where's the scene? Okay, and Nick, make sure you're not doing anything embarrassing. Thank you, I appreciate that. Okay. If you're still watching, I'm assuming that the class is ready to hear this. So, Heathcliff has a stand selling cookies, cost him $12 to buy supplies. All right, first of all, I'm going to go for my independent and my dependent variables. And that looks like p-pendant, and I don't want a p-pendant, so I will change that to dependent. All right, and let's see, what two things are changing? Well, it looks like the cookies sold are changing. And let's see, where's that function equation here? Where's that function? Where does it say? Write a function. Write a function that can be used to determine the amount of money he makes from selling cookies. The two things that are changing are the cookies, number of cookies sold, and the money he's made. Now, which one causes the change? Does the money being made cause a change in the selling of cookies? Or does selling a cookie cause the amount of money you've made to change? What's that, Ariana? You're absolutely right. The independent variable is the cookies that are sold. It causes a change in the amount of money. So the dependent variable is the amount of money. Okay. And maybe I'll do that as m. All right, now I'm ready to write my function. So I'm going to take m of c, and let's see, what does he start with? He buys supplies for $12, so he's going to start in the hole $12, and then he gets to add 25 cents for every cookie he sells. All right, there we go. There's my function. Let's do my domain and my range. So my domain is concerned with C. Well, C is limited. He's only allowed to sell 169 cookies. Mom and Dad have told him to not make any more. So the domain is going to be all the possible numbers of cookies it can sell. Well, the most it can be is 169. But the least it can be is 0 if he doesn't have any sales. There is my domain. Okay, my range, I got to be careful on this one. The least amount of money he makes is not 0 because he spent $12 of his own money on buying the stuff to make the cookies. So if he doesn't sell a single cookie, he's really made negative $12. All right, and then the maximum number would be 169 times a fourth. But then once you got that answer, you'd subtract the $12. And I think it comes out to be $30.25. I seem to remember that number. All right, I hope that's right. Okay, Let me just check my math here really quick. We have 169 times a quarter, and I will subtract $12. And there we go, $30.25. We're good. Notice I didn't go to the calculator first. I used the calculator to check my answer. Okay, now we need to know, is this continuous or is this discrete? Well, you could figure out 0 cookies, he's made negative $12, right? If he sells, let's see, 12 cookies, he's going to be at negative $9, etc. Can the points in between the data make sense? In other words, what if he sells 2.5 cookies? Well, in this case, it doesn't make sense because he says it's saying that he's selling them for 25 cents a piece. All right, so there's that problem. Okay, moving right along. So that means it's discrete data. Sorry, I didn't say that. Okay, here's number 6. Make a table and graph the function. What type of function is it? I'll let you pause. If you're still watching, I assume you're ready. I'm going to do x and then j of x. And let's see, I'm going to pick 5 values. And let's see here, it's going to be 4, that's going to be 1. That's, oh, no, that's not going to be 1, that's going to be 2. That's going to be 1. 2 to the negative first is 1/2, and 2 to the negative second is 1/4. All right, so a little sketch graph is going to cause this to look something like this. It's going to look a little sloppy. I'm starting to run out of time here. The bell's about to ring, and I don't want to have to redo the video. So 0 is at 1, 2 is at 4, and then it's going to go down like this. So, and this is, of course, is an exponential function. Okay, it's exponential. By the way, if there's no story to it, you can assume the function is continuous. Okay? All right, here's one more sample. You need to determine which of these input-output tables matches the function and the graph. So does it go with A, B, C, or D? I'm going to let you decide that on your own. Okay, the video is about to end. After you've decided, if you need to see it again, that's fine. If not, you may work on that Chapter 3 assignment in digits using the computers, or you can use computers to work on your midterm review. All right, that's it. Mr. Lawrence signing off. Have a good night, everybody.